China did not start a war. No missile was launched against the United States. Not a single Chinese soldier entered the battlefield. Not a single Chinese warship sailed into the Persian Gulf. And yet, in April 2026, every American aircraft carrier, every destroyer, every submarine, and every warship operating near the Strait of Hormuz is facing a reality Washington spent decades believing it could avoid. Exposure, not exposed to a conventional Chinese attack. No exposure to a declared Chinese military campaign. Exposure to a system. A satellite network has done what decades of American military planning never fully anticipated. It has made U.S. naval power visible, trackable, and potentially targetable inside one of the most confined and strategically important waterways on Earth. That system is China's BeiDou-3, and what has happened over the waters of Hormuz may have permanently changed the rules of naval warfare. Think about the picture for a moment. The USS Dwight D. Eisenhower and the USS Carl Vinson, two full-carrier strike groups deployed in and around the Persian Gulf. Alongside them are destroyers, submarines, aircraft, F/A-18 Super Hornets, electronic warfare platforms, missile defense ships, and the most advanced naval command structure ever built. This is still the most powerful naval force on Earth. But power is not the same as invulnerability. And the Pentagon is now confronting a question it does not yet have a complete answer for. What happens when the most powerful fleet in the world can be continuously tracked by a foreign satellite system and targeted through a precision guidance network it does not control? That is the real danger. This is not a Chinese missile attack. It is not the beginning of open war between Beijing and Washington. It is something quieter and, in some ways, more unsettling. It is a technological defeat unfolding without a formal battlefield. China has built a surveillance and precision guidance ecosystem capable of tracking U.S. naval movements and giving American adversaries a better targeting picture than they ever had before. Iran does not need Chinese sailors in the Gulf if Chinese satellites can provide the data. It does not need Chinese pilots in the sky if Chinese navigation systems can help guide missiles. This is how 21st century power works. Influence without presence, participation without fingerprints, escalation without a declaration of war. For nearly 80 years, the United States Navy operated under a central assumption: it could project force into any ocean, any choke point, any crisis zone, and any regional conflict with overwhelming advantage. Carriers could arrive, establish air superiority, shape events, and deter adversaries from direct challenge. That assumption depended on something invisible. The belief that adversaries could not reliably find, track, and strike American naval formations with precision under real combat conditions. After February 2026, that belief is no longer secure. The weapon that challenged it was not a new Chinese battleship. It was not a hypersonic missile launched from the mainland. It was a constellation of satellites orbiting silently above the Earth. BeiDou-3 did not fire a shot, but it changed the battlefield. Most people think BeiDou is simply China's version of GPS, a navigation system, a Chinese alternative to the American satellite network used for maps, timing, and positioning. That assumption is dangerously incomplete. BeiDou is not just a navigation service. It is a strategic infrastructure system. Its military-grade signal is encrypted. It is designed to resist spoofing. It uses authentication techniques to make false signals harder to inject. It is supported by frequency, agility, and layered satellite coverage. And unlike GPS, BeiDou includes a short message communication function that allows limited data transmission through the satellite network. That matters because navigation alone tells a missile where it is. Communication can help tell it where to go next. In a moving naval environment, that distinction is critical. A ship is not a fixed target. A carrier strike group is constantly moving, shifting formation, changing course, repositioning escorts, and managing defensive geometry. A missile launched at coordinates that were accurate 10 minutes ago may miss if the target has moved. But if a missile or drone can receive mid-course updates, the kill chain becomes far more dangerous. Detection, tracking, targeting, launch, mid-course correction, terminal guidance, impact. That is the chain China's system threatens to strengthen. The Strait of Hormuz makes this even more dangerous because geography compresses everything. The waterway is narrow, the maneuvering space is limited, naval formations have less room to disperse. Missile flight times shrink, defensive reaction windows become smaller, electronic warfare becomes more crowded. The difference between a target being somewhere in the Gulf and being tracked inside a constrained maritime corridor is enormous. That is why Hormuz matters. It is not just a waterway. It is a test chamber. In open ocean, a carrier strike group has distance, depth, and maneuver space. In Hormuz, it operates inside a geographic funnel, where precision tracking becomes far more consequential. And this is where BeiDou changes the logic. China's satellite architecture is built across multiple orbital layers. Medium Earth orbit satellites provide broad global coverage. Geostationary satellites remain fixed over key regions, giving stable signal availability. Inclined geosynchronous satellites strengthen coverage and geometry across priority zones. This multi-orbit structure improves what engineers call signal geometry. When more satellites observe a receiver from more angles, positioning accuracy improves. In a military environment, better geometry means more reliable guidance, better timing, and stronger resilience against disruption. But BeiDou's role in this crisis is not limited to navigation. China also operates a much broader space network: reconnaissance satellites, Earth observation platforms, electronic intelligence satellites, ocean surveillance assets, and data relay systems. When navigation is integrated with surveillance, the result is not simply a map. It is an operational picture. Where is the carrier? What direction is it moving? How fast? Where are the escorts? Which ships are screening the formation? Which platforms are emitting radar? Which aircraft are launching? Which defensive systems are active? That is the information modern missile warfare needs. A missile without targeting data is only a weapon. A missile with real-time targeting support becomes part of a system, and systems are what defeat fleets. This is the part that should worry Washington most. The United States is not merely facing Iranian missiles. It is facing an emerging technological ecosystem in which Iran provides the launch platforms, China provides precision and surveillance, and Russia contributes additional hardware, air defense, and reconnaissance support. That does not mean China and Russia are formally at war with the United States. It means the battlefield has become networked. Russia's role strengthens Iran's military environment through aircraft, air defenses, electronic warfare tools, and satellite-linked reconnaissance. China's role strengthens precision, navigation, surveillance, and potentially targeting. Iran's role is to absorb pressure, launch weapons, and generate live battlefield data. America is no longer dealing with a single opponent operating in isolation. It is facing an integrated multinational technology stack. That is a very different problem from the one U.S. planners were trained to solve during the First Gulf War. In 1991, the United States shocked the world with precision warfare. GPS-guided weapons, laser-guided bombs, cruise missiles, and satellite-enabled targeting became symbols of American dominance. The message was clear. America could see farther, strike more accurately, coordinate faster, and destroy more precisely than any adversary. The world watched. Then the world learned. China learned especially deeply. During the 1996 Taiwan Strait crisis, Beijing experienced what it considered a strategic humiliation. China fired missiles near Taiwan as a warning. The United States responded by sending carrier forces into the region. According to widely repeated accounts, Chinese missile performance was affected by dependence on systems the United States could influence, disrupt, or deny. Whether every detail of that episode is debated or not, the strategic lesson Beijing took from it was unmistakable. China could not depend on American-controlled navigation infrastructure. A country that relies on another country's positioning system is not fully sovereign in war. That lesson became one of the driving forces behind BeiDou. The program developed in phases. Initial capability came first. Regional coverage across the Asia-Pacific followed. Then came global coverage with BeiDou-3. By 2020, China had built a full global navigation system with military applications, encrypted services, and strategic independence from GPS. What America once used as a tool of dominance became the model China used to build independence. And now that independence is being tested in the most strategically sensitive waterway in the world. The military logic is simple. If the United States can jam or spoof GPS, Iran can use BeiDou. If one signal is degraded, another can provide redundancy. If navigation is paired with inertial guidance, terrain matching, radar seekers, or terminal homing, missile accuracy becomes harder to defeat. If surveillance satellites provide updated target data, missiles can be launched with better confidence. And if short message communication can support mid-course updates, a moving ship becomes more vulnerable than it was in the old model. That does not mean every Iranian missile becomes unstoppable. It does not mean American carriers are helpless. It does not mean BeiDou has magically neutralized the U.S. Navy, but it does mean the margin has changed. And in naval warfare, margin is everything. A carrier strike group survives through layered defense, distance, deception, maneuver, electronic warfare, air superiority, missile defense, decoys, hard kill interceptors, soft kill systems, and command discipline. The point is not that one layer is perfect. The point is that the enemy must defeat all of them under pressure. BeiDou does not remove those layers. It sharpens the enemy's first step. It improves the ability to find and target. And if the first step improves, every later step becomes more dangerous. That is why U.S. carrier doctrine is under pressure. For decades, the carrier's presence was itself a strategic message. A carrier could move into a crisis zone and force adversaries to recalculate. It carried aircraft, missiles, intelligence systems, and command authority. It could strike deep inland. It could control airspace. It could support allies and threaten enemies. But that doctrine assumed that the carrier could operate at manageable risk. In Hormuz, the risk equation changes. A confined waterway, a nearby adversary, dense missile inventories, drones, coastal launchers, submarines, mines, and now a foreign satellite navigation and surveillance network all combine to challenge the old model. The question is no longer simply, can the carrier project power? The question becomes, can the carrier survive long enough, close enough, under enough targeting pressure to project power without unacceptable risk? That is the question now haunting naval planners. And there is no easy answer. The United States can adapt. It still has the world's most capable Navy. It has unmatched experience in integrated air and missile defense. Aegis ships remain formidable. American submarines remain extraordinarily difficult to track. U.S. electronic warfare remains advanced. American pilots, crews, and commanders train for exactly these high-stress environments. But adaptation takes time. New countermeasures take time. New doctrine takes time. New distributed force structures take time. New space defense concepts take time. Meanwhile, BeiDou is already deployed. That is the asymmetry. China spent 30 years building the system. The United States must now respond to its battlefield effects in real time. There is another layer to this story that goes beyond Iran. Hormuz is not the final exam for China. Taiwan is. Everything China learns in the Gulf can feed its thinking about a future Taiwan crisis. Every missile fired under BeiDou guidance tells Beijing something. Every American interception attempt tells Beijing something. Every electronic warfare sortie tells Beijing something. Every radar emission, every jamming attempt, every successful intercept, every failed intercept, every delay in the kill chain becomes data. Hormuz is the laboratory. Taiwan is the real test. For Beijing, Iran is a useful partner because it creates a live environment where Chinese systems can be observed under pressure without China directly entering the war. The United States must respond. Iran fires, American defenses activate, sensors collect. Analysts study, lessons flow back into future planning. This is not traditional proxy warfare. It is proxy data warfare. The goal is not only to help Iran, the goal is to understand America. How does Aegis respond to missiles guided by non-GPS systems? How effective are U.S. jammers against authenticated signals? How quickly can U.S. ships change formation under targeting pressure? How do F-35s operate near radar systems designed to challenge stealth? How do carrier strike groups behave when surveillance is persistent? These questions matter enormously in a Taiwan scenario. A future conflict in the Taiwan Strait would also be defined by confined waters, missile saturation, space-based surveillance, electronic warfare, and the challenge of keeping U.S. naval forces at risk before they can intervene decisively. That is why China can remain officially neutral while still learning from every second of the crisis. Beijing can call for restraint. It can request United Nations discussions. It can speak the language of peace. And at the same time, its technology can reshape the battlefield. That is modern strategic competition. Official neutrality on the surface. Operational relevance underneath. This is also why the United States cannot treat the Hormuz crisis as only a Middle Eastern problem. It is also an Indo-Pacific problem. It is also a space problem. It is also an electronic warfare problem. It is also a doctrine problem. The crisis reveals that American military dominance has entered a new phase, not collapse, not defeat, but contestation. The era when the United States alone controlled precision warfare is ending. GPS is no longer the only global navigation system that matters. Russia has GLONASS, Europe has Galileo, China has BeiDou, India has regional systems. The world is moving toward a multipolar satellite navigation environment. That single shift undermines a large portion of military doctrine built after 1991. For decades, GPS denial was one of America's major advantages. If an adversary depended on GPS, the United States could disrupt, degrade, or manipulate that dependence. But if adversaries can shift to BeiDou, GLONASS, Galileo, inertial systems, terrain matching, and multi-source navigation, the old denial model weakens. America's electronic warfare advantage does not disappear, but it becomes less decisive. That is the deeper meaning of the BeiDou challenge. It is not only that China built a better navigation tool, it is that China helped create a world where American control over precision warfare is no longer exclusive. That is a strategic revolution. Still, serious analysis requires limits. It would be propaganda to claim that BeiDou alone has defeated the U.S. Navy. It has not. It would be exaggerated to say American carriers are helpless. They are not. It would be simplistic to say China can now sink any U.S. ship at will. It cannot. Missile warfare is complex. Targeting ships at sea remains difficult. Satellites can be blinded, spoofed, deceived, attacked, jammed, or overwhelmed. Data links can fail. Missiles can be intercepted. Terminal seekers can be confused. Command chains can break under pressure. The U.S. Navy has many ways to fight back. But the balance has shifted. That is the point. The margin has narrowed. The problem has become harder. And Hormuz is the place where the world can see it. The CM-302 anti-ship missile deal, the BeiDou integration, the satellite tracking architecture, the Russian hardware, the Iranian launch platforms, the U.S. carrier deployments, the Aegis defensive network, and the confined geography of the Strait all combine into a single strategic picture. Naval dominance is no longer guaranteed by presence alone. Presence must now survive precision. That is the new rule, and it changes everything. If Iran threatens to close Hormuz, the world faces an economic shock. Roughly 1/5 of global oil flows through or near that corridor. Any disruption would hit markets within days. But the military danger is even more immediate. In a crowded theater, one misidentified aircraft, one missile launched too close to a carrier group, one accidental strike, one failed interception, or one misunderstood signal could escalate the crisis beyond anyone's original plan. The diplomatic system may be active, but the military system is under pressure. That is how wars expand. Not always through grand decisions, sometimes through compressed reaction times, crowded airspace, and technologies no one fully understands under combat conditions. And China's role makes this even more complicated. Beijing is not officially a combatant, but its systems are embedded in the conflict. That creates a new gray zone. At what point does providing surveillance and guidance become participation? At what point does satellite data become a weapon? At what point does neutrality become fiction? Those questions do not yet have stable answers. But future wars will revolve around them. In the 20th century, neutrality was measured by troops, ships, and weapons deliveries. In the 21st century, neutrality may be measured by data. Who provides the coordinates? Who authenticates the signal? Who maintains the satellite link? Who updates the target? Who sees the battlefield? That is where power now lives. China fired no shots in Hormuz, but it changed the battlefield. No Chinese warship entered the Gulf, but Chinese satellites were overhead. No Chinese pilot flew against American aircraft, but Chinese-linked systems shaped the operating environment. This is why Pentagon planners should be awake at night, not because the United States has been defeated, but because the nature of the contest has changed faster than doctrine can comfortably absorb. The U.S. Navy remains unmatched in total capability, but the cost of operating inside adversary precision networks is rising. The freedom to move close to hostile shores is shrinking. The assumption that carriers can dominate any crisis zone by arrival alone is being tested. And the answer is still being written. China spent 30 years building a way to escape American navigation dominance. Now that system is operational above Hormuz. Iran is using the battlefield. Russia is adding hardware. America is adapting under pressure. And Beijing is watching every result. That is the real story. Not that China started a war. It did not. Not that China defeated the United States. It has not. But that China helped create a battlefield where American naval power can no longer assume invisibility, immunity, or uncontested precision superiority. The old age of naval dominance was built on reach. The new age will be built on survivability inside hostile sensor networks. And in that new age, the most dangerous weapon may not be the missile. It may be the satellite that tells the missile where to go. That is what Hormuz has revealed. And that is why this moment matters far beyond Iran. Because the next time this system is tested, the waterway may not be Hormuz. It may be Taiwan.